Hello and welcome to today's lesson on the Introduction to Logic. Alright, Introduction to Logic. So, logic, we deal with something called statements. So, what is a statement? A statement is a declarative sentence that has a value of either true or false. So here are some examples. Mr. Moore is a math professor. That statement is true. Mr. Moore is left-handed. That statement is false. So both of those two statements, they're both declarative sentences, and they have a value of either true or false. All right, the next one, Mr. Moore will live until he is 100 years old. Well, that statement has a value of either true or false. We just don't know which it's going to be at this point in time, but it does have a value of true or false. So that is also a statement. Now the next one, we have he is a carpenter. Well, that is a declarative sentence, but since we don't know who he is, then this is not considered to be a statement. So he is a pronoun which represents some person, and we don't know who that person is. In a similar fashion in algebra, if we have x plus 3 is equal to 8, well, that x represents some value, some unknown value. So this is not considered a statement either. Now, whenever you were learning your algebra classes, whenever we see a sentence like this, x plus 3 is equal to 8, in algebra we assume that the sentence is true. In other words, we assume that it is a statement, and then we proceed to find out the value of x. That makes it a true statement. But if you were just to say x plus 3 is equal to 8, that's not really considered to be a statement because we don't know what x is. Alright, the sentence, do your homework. Well, this is not a declarative sentence, and therefore it is not a statement. The question, did you do your homework? Well, that is not a declarative sentence, so that is not a statement either. Alright, so our next definition is a simple statement. A simple statement is a declarative simple sentence that has a value of either true or false. In other words, the statement has one subject, one verb, and one object. That's what a simple sentence is. So a simple statement is a simple declarative sentence. In other words, it has one subject, one verb, and one object, and it has a value of either true or false. A compound statement is one or more simple statements with connectives, such as and, or, not, the if-then connective, and the if and only if connective. Alright, so now let's take a look at symbolic logic. So in logic, and one of the things we're going to be doing is we're going to be using variables to represent statements. Typically we'll be using variables like P, Q, R, and S. So here is a couple of examples. Statement P is Mr. Moore likes Star Trek. Statement Q is Mr. Moore has perfect vision. So we like to convert statements to variables in order to analyze what happens when putting the statements together using connectives. We want to be able to determine the truth value of the compound statements by knowing the truth value of the components. And by using variables, then we eliminate any personal bias we might have with regards to the text of the statement. So let's take a look at some connectives. So, the first connector we're going to talk about is something called the negation. For the negation, we use this little curly dash that actually has a name. It's called tilde. So to indicate the negation of statement, that negation of P, that little dash P that is read the negation of P, or sometimes just not P. So if I have the statement P, Mr. Moore likes Star Trek, then the negation of P would be Mr. Moore does not like Star Trek. We have negated the original statement. Now let's take a look at our next connective, something called the conjunction. So the conjunction symbol, we're going to use this little caret symbol to indicate our conjunction. Alright, so that conjunction, this is going to be read the conjunction of P with Q, which is sometimes read P and Q. So your conjunction goes with the word and. And an example would be something like this. So if I have the two sentences, two statements, P, Mr. Moore likes Star Trek, and Q, Mr. Moore has perfect vision, and I wanted to find the conjunction of P and Q, then that's going to be the following. Mr. Moore likes Star Trek, and Mr. Moore has perfect vision. Now, if we take a look at this previous example, you notice what I have is two complete sentences with the connective between them. But we can also condense this statement to read something like this. Mr. Moore likes Star Trek and has perfect vision. So when we condensed it like this, what we had is one subject and two predicates. But whenever we take a look at the symbolic logic version of it, we have to look at it as two simple sentences, where each one has one subject and one predicate. Now let's take a look at the disjunction. So the disjunction symbol, we're going to use this symbol here that looks kind of like a V. So we will have P disjunction with Q. Now the word that goes with disjunction is going to be or. So let's take a look at some examples. So let's say I have the statement P is Mr. Moore likes Star Trek, and Q is Mr. Moore has perfect vision. So if we want to find the disjunction of P and Q, then that's going to be Mr. Moore likes Star Trek, or Mr. Moore has perfect vision. Alright, the next connective is something called the conditional. For the conditional statement, we're going to use this arrow. So here I have P conditional Q, which a lot of times is read if P, then Q. That's our conditional statement. The conditional statement is the if-then statement. So if I do my example here, so if P is Mr. Moore likes Star Trek, and Q, Mr. Moore has perfect vision, and if I wanted to build an if-then statement with those two, build a conditional, if P then Q, then this would read, if Mr. Moore likes Star Trek, then Mr. Moore has perfect vision. And again, in a later lesson, we'll take a look at what it means for if the individual components are true or false, what it means if you put the if-then together when the if-then statement is true or false. Now let's take a look at the biconditional. This is going to be our last connective for today. So the biconditional uses a double arrow to indicate the biconditional of two statements. That is going to be read P if and only if Q, or P biconditional Q. So if I have the statements P, Mr. Moore likes Star Trek, and the statement Q, Mr. Moore has perfect vision, then to find the biconditional of P and Q, that would be read Mr. Moore likes Star Trek if and only if Mr. Moore has perfect vision. Alright, thank you for watching this video, and I hope you watch more of these. Thank you.